Okay, I'm going to fly through this video a bit more. It's really following the same steps as the second video, so you can go review that if you need to. If you remember, the exponent that we really wanted to raise Fenthion to was 2.4. So let's see what happens when we do that. We're going to do Fenthion 2.4, create that column, and just raise Fenthion to the 2.4 power. Easy enough. And we're then going to go through the descriptives. I'm just going to jump straight to the ANOVA here. So we can take a look. Oh, now we have Fenthion to 2.4 as our dependent. Day is still our factor. And let's go ahead and at least peek at the homogeneity test in QQ plot. So the normality of the residuals still looks fine. These dots are roughly following the line. No clear trends otherwise. And the Levines, which remember we want to fail to reject, that would tell us that it's okay to assume the population variances are equal. And here we're even further away from that 0.05 than we were when we did the square of the Fenthion. So this is looking great in terms of assumptions. The standard deviation or variance of our three groups are relatively equal. And just to clarify, when I say standard deviation and variance, I'm using them interchangeably because the variance is always the square of the standard deviation. So if the standard deviations are equal, then the variances are equal also. So they're interchangeable in the sense that the way we're using them, it's the same, even though really the variance is the square of the standard deviation. Okay, so if we look at our ANOVA results, we're going to meet the assumptions here. So we're looking at the results. We certainly have a significant result again, and we have our F test right there. So also a very high F value. What we might want to do then is take a look at our contrasts. We'll grab those 95% confidence intervals and just do the simple ones again, simple contrasts. And if you can hopefully see down here, the difference between the initial content of Fenthiol to the 2.4, that's where it gets a little weird, and the Fenthiol to the 2.4 on day 365, it looks like that's decreased by between 3.56 and 4.56. And again, this is units to the 2.4. So we would then want to take the 2.4th root, I guess you would say. You would take the absolute value and then to 1 over 2.4 to get the actual amount of fentanyl. The bigger question then in part C, which model is better? Really, I mean, in both parts B and C, we meet the assumptions. Looks like 2.4 is probably going to give us a slightly more accurate response. We are pulling those variances together even more closely. The squared might be a little more comfortable for people if you had to interpret it. So I think this would be a case where either model would be a reasonable model. The 2.4 might be slightly more precise, but also more confusing. So from personal experience, I probably would opt for the one that was just the squared version, especially since there wasn't much of a difference in the precision otherwise. Okay.